March 6, 1944. Beneath the grey winter sky over Berlin, Oberleutnant Heinrich Setz craned his neck upward from the cockpit of his Messerschmitt Bf 109. His leather gloves gripped the control column as he scanned the contrail-streaked heavens above the German capital. What he saw defied every briefing, every intelligence assessment, every tactical assumption his commanders had drilled into him over the past 2 years. Weaving through the bomber formations at 28,000 feet, their silver wings glinting in the pale sunlight, were American single-engine fighters. Not the expected Thunderbolts or Lightnings turning back at the edge of their fuel range. These were Mustangs, over Berlin, 560 miles from their bases in England. The Luftwaffe High Command had insisted this was impossible. The mathematics were clear, the fuel calculations absolute. Single-engine fighters simply could not carry enough fuel to escort bombers to the Reich capital and still have reserves for combat. Yet here they were, engaging aggressively, maneuvering with full combat capability, showing no signs of fuel conservation whatsoever. The Americans had rewritten the equation, and for the German fighter pilots who had built their defensive strategy around the Allies' range limitations, this moment marked the beginning of the end. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The story of how the Luftwaffe's most experienced aces came to underestimate and then face the brutal reality of the P-51. Mustang's range begins not with German miscalculation, but with a series of very reasonable assumptions based on hard evidence. In late 1943, Luftwaffe intelligence had meticulously documented the combat radius of every Allied fighter operating over occupied Europe. The Republic P-47 Thunderbolt, a magnificent aircraft powered by a massive radial engine, could reach approximately 375 miles from its English bases with standard drop tanks. The Lockheed P-38 Lightning, despite its twin engines, faced similar range constraints. These limitations had shaped German defensive doctrine throughout 1943. Luftwaffe fighter controllers positioned their squadrons strategically, waiting for the inevitable moment when Allied escorts reached their fuel limits and turned for home. Then, and only then, would German fighters swarm the unprotected bomber formations. This tactic had proven devastatingly effective. On October 14, 1943, a day that would be remembered as Black Thursday, American bombers struck the ball-bearing factories at Schweinfurt deep inside Germany. Of the 291 B-17 flying fortresses dispatched, 60 were shot down by German fighters and flak. Another 17 were damaged so heavily they had to be scrapped upon return to England. The losses represented over 26% of the attacking force. Among those analysing the wreckage and intelligence reports from that mission was General Major Adolf Galland. At 31 years old, already the General der Jagdflieger, the commanding general of all Luftwaffe fighter forces. Galland was no desk officer. With over 100 confirmed aerial victories, he understood combat from the cockpit up. His assessment of Allied fighter capabilities was based not on wishful thinking but on mathematical certainty. The distance from English bases to Berlin measured approximately 560 miles one way. For a round-trip escort mission, fighters would need to fly 1,120 miles. Add in combat maneuvering, the fuel-intensive climbs to altitude, and reserve margins for emergencies. And the fuel requirement became prohibitive for single-engine aircraft. The P-47 Thunderbolt, despite its power and effectiveness, as a fighter, consumed fuel at rates that limited its penetration into German airspace. Even with external drop tanks, the Thunderbolt had to turn back somewhere around the German border, leaving the bombers to fend for themselves over the target areas deep in the Reich. German intelligence officers had captured several P-47's and conducted exhaustive technical evaluations. They knew precisely how much fuel the aircraft carried, how quickly it burned through that fuel at various power settings, and where its absolute maximum range ended. Similar analyses had been performed on the P-38 Lightning. While its twin engines theoretically offered redundancy for long over-water flights, they also meant double the fuel consumption. The Lightning's operational radius, while respectable, fell well short of Berlin. These weren't estimates or guesses. Luftwaffe technical intelligence services operated with Germanic precision, measuring, calculating, and verifying every specification of captured Allied aircraft. The conclusion was unambiguous and repeatedly confirmed. American single-engine fighters could not escort bombers to Berlin and return. This assessment would prove to be simultaneously correct and catastrophically wrong. Correct in its technical analysis of existing American fighters. Wrong because it failed to account for an aircraft that was about to transform the air war over Europe. The North American P-51 Mustang had begun its life in 1940 as a hastily designed fighter built to a British Purchasing Commission's requirements. The British Royal Air Force, desperate for modern fighters during the dark days of 1940 and 1941, had approached North American aviation seeking a licensed production version of the Curtiss P-40. Instead, North American's chief designer Edgar Schmood proposed building an entirely new fighter that could be developed faster and perform better than the P-40. Remarkably, North America committed to delivering a flying prototype in just 120 days. The NA-73X prototype completed its first flight on October 26, 1940, just 117 days after the contract was signed. The early Mustangs, powered by Allison V-1710 engines, proved to be excellent aircraft at low and medium altitudes. The Royal Air Force deployed them primarily for tactical reconnaissance and ground attack roles. Their range was already impressive, with internal fuel capacity providing roughly 750 miles of range, but they lacked the high-altitude performance necessary to engage German fighters escorting bomber formations at 25,000 to 30,000 feet. The Allison engine, lacking an efficient high-altitude supercharger, simply couldn't generate sufficient power in the thin air above 20,000 feet. The transformation came when British engineers at Rolls-Royce experimented with installing their Merlin 61 engine in a Mustang airframe. The Merlin, already powering Spitfires and Lancasters, featured a two-stage supercharger that delivered excellent high-altitude performance. The results of this marriage between the American airframe and British engine were extraordinary. The Merlin-powered Mustang suddenly possessed not only its inherent range advantage, but also the high-altitude performance to dominate any German fighter above 20,000 feet. The American Packard Motor Company, already producing Merlins under license in Detroit, began supplying engines for North American's production lines. By December 1943, the first P-51B Mustangs, equipped with Packard-built Merlin engines, began arriving in England with the U.S. 8th Air Force. These aircraft featured two wing tanks holding 92 gallons each, for a total of 184 gallons in the wings. Additionally, later production P-51Bs incorporated an 85-gallon fuselage tank positioned directly behind the cockpit. This brought total internal fuel capacity to 269 gallons. With the Merlin engine consuming approximately 60 to 75 gallons per hour at cruise power settings, the basic mathematics suggested a flight endurance of roughly 3.8 to 4.5 hours. At cruising speeds of approximately 300 miles per hour, this translated to a maximum range of around 1,140 to 1,350 miles, enough to reach Berlin from England. Barely. But these calculations represented ideal conditions, assuming no combat, no maneuvering, perfect weather, and no reserves. Real combat operations required fuel for takeoff, assembly into formation, climb to altitude, navigation adjustments, combat maneuvering, and sufficient reserve to account for headwinds on the return journey. The experienced German intelligence officers analyzing these figures would have concluded that while the Mustang's range was impressive, it still fell short of providing practical bomber escort to Berlin with sufficient combat reserves. They were working with incomplete information. The critical missing element in Luftwaffe calculations was the full extent of American industrial innovation applied to the external fuel tank problem. Drop tanks, or external fuel tanks that could be jettisoned when empty or when entering combat, were not new technology. German fighters had used them since the Battle of Britain. The Messerschmitt Bf 109 could carry a 300-litre drop tank. The Focke-Wulf FW-190 regularly employed them for extended-range missions. The concept was straightforward: carry additional fuel externally, then release the tanks before engaging enemy aircraft to restore the fighters' performance and maneuverability. What German intelligence failed to fully appreciate in the winter of 1943 to 1944 was the scale and sophistication of Allied drop tank production, particularly a revolutionary British innovation that was being rapidly adopted and mass-produced by American industry. In late 1943, British engineers working for the Bowater Scott Corporation had developed drop tanks manufactured not from strategic metals like aluminum or steel, but from laminated kraft paper impregnated with phenolic resin. These paper drop tanks could hold 108 U.S. gallons of aviation fuel, weighed approximately 80 pounds empty, and most critically, could be mass-produced using paper mills and packaging facilities rather than scarce metalworking capacity. The innovation had been driven by British resource constraints. By 1943, Britain's aluminum supplies were stretched thin across aircraft production, shipbuilding, and countless other military requirements. Using paper for drop tanks freed precious aluminum for aircraft structures, while providing a product that, though single-use and disposable, functioned perfectly for its intended purpose. The tanks were manufactured in three main sections: a nose cone, tail cone, and cylindrical body. Multiple layers of heavy kraft paper were laminated with resinol formaldehyde glue, wrapped around forms, then coated with fuel-resistant lacquer. Internal wooden anti-slosh baffles prevented fuel from surging during maneuvers. Brass fittings provided secure fuel connections. The entire construction process, while requiring precision, could be performed by semi-skilled workers after minimal training. By early 1944, these paper tanks were entering mass production not only in Britain but also in facilities across the United States. The implications were staggering for anyone who truly understood them. These tanks didn't require aluminum, steel, or other strategic materials. They could be manufactured in virtually unlimited quantities using widely available resources. They were completely expendable by design, meant to be dropped over enemy territory and never recovered. A single P-51 Mustang carrying two 108-gallon paper drop tanks possessed a total fuel capacity of 485 gallons. With this fuel load, the Mustang could fly for approximately 6.7 hours at cruise power, yielding a range exceeding 2,000 miles. This was more than sufficient for the Berlin mission with substantial combat reserves. But in February 1944, Luftwaffe intelligence had not yet grasped the full scope of this development. German technical services knew Allied fighters were using drop tanks. They had recovered examples from downed aircraft and crash sites. What they hadn't yet fully calculated was the combination of the Mustang's exceptional aerodynamic efficiency, its fuel-efficient Merlin engine, its large internal fuel capacity, and these new high-capacity disposable external tanks. The mathematics of aerial warfare were being rewritten, and the Luftwaffe's defensive strategy, built on assumptions of Allied range limitations, was about to become obsolete. The transformation came with shocking suddenness. On March 4, 1944, the U.S. 8th Air Force launched its first major daylight bombing raid on Berlin. The mission briefing that morning at bases across England revealed what many pilots had thought impossible. The red ribbon on the mission map stretched from their airfields all the way to the German capital and back, a round trip of over 1,100 miles. For the first time in history, single-engine fighters would escort bombers to Berlin. Colonel Donald Blakesley's 4th Fighter Group, flying P-51 Mustangs they had received just days earlier on February 28, would lead the escort. Many pilots had less than an hour of flight time in the new aircraft. Some, like Captain Don Gentile, who would become one of the war's top aces, had exactly 45 minutes in the Mustang before, in his first combat mission. The ground crews had worked through the night, mounting the new paper drop tanks under each fighter's wings. These silver-painted cylinders looked almost too simple, too insubstantial for their critical purpose. Some pilots joked about flying to Berlin with fuel carried in what appeared to be glorified cardboard tubes. The first mission on March 4th was hampered by weather and communication problems. Only 32 bombers reached the target, but the strategic significance was unmistakable. American single-engine fighters had reached Berlin, engaged Luftwaffe interceptors over the German capital, and returned to England. This was not a one-time penetration or a desperate all-or-nothing mission. The Mustangs had flown the distance with fuel to spare, fought effectively, and came home. 2 days later, on March 6th, approximately 660 bombers attacked Berlin in daylight, escorted by over 150 P-51 Mustangs, along with P-38 Lightning and P-47 Thunderbolt groups. The Mustangs, with their superior range, provided continuous escort throughout the mission profile. German fighters attempting to attack the bomber formations found themselves engaged by American escorts before they could close to effective firing range. General Major Galland, despite his administrative position as General der Jagdflieger, still flew combat missions when possible. He encountered P-51 formations over Germany during this period and immediately recognized the implications. His combat assessment reports, submitted through official Luftwaffe channels, noted that American fighters were operating at full combat capability over Berlin, engaging aggressively with no apparent fuel conservation behavior whatsoever. They weren't flying at the limits of their range, they had reserves, they could afford to fight. This contradicted everything Luftwaffe intelligence believed about American fighter capabilities. The defensive strategy that had worked throughout 1943, waiting for Allied escorts to reach their fuel limits before attacking bombers, was suddenly worthless. German fighters now had to engage the escorts to reach the bombers, and those engagements were proving costly. Galland's technical assessments emphasized the P-51's superior performance at high altitude, where it outmatched both the Messerschmitt Bf-109 and Focke-Wulf FW-190 in speed and maneuverability above 20,000 feet. Combined with range sufficient to escort bombers anywhere in Germany, the Mustang had fundamentally altered the strategic balance. The Luftwaffe's intelligence services moved quickly to understand how the Americans had achieved this capability. The examination of captured enemy aircraft was a critical function of the Reich's technical intelligence organizations. At Rechlin-Lehrs, the Luftwaffe's primary aircraft testing and evaluation center in Mecklenburg, teams of engineers and pilots worked systematically to analyze every advantage the Allies possessed. A captured P-51 Mustang arrived at Rechlin on March 6, 1944, transported by rail from a crash site near Brandenburg. The aircraft had been shot down 2 days earlier during one of the first American fighter escort missions to Berlin. The pilot had not survived, but the airframe remained largely intact. Hermann von Baumbach, who served in aircraft development and would later command Special Operations Forces, oversaw the initial examination. The young American pilot's navigation charts, still in the cockpit, showed the route from an airfield at Debden in England to Berlin and back, a distance of over 1,100 miles round trip. The technical evaluation began immediately, focusing first on fuel capacity and range calculations. German engineers measured the P-51B's internal fuel capacity with characteristic precision. The aircraft featured 2 wing tanks, each holding 92 gallons for 184 gallons total. The fuselage tank held 85 gallons, total internal capacity, 269 gallons. The Packard-built Merlin engine consumed approximately 60 gallons per hour at economy cruise, 75 at normal cruise. At these consumption rates, with internal fuel only, the P-51 could fly for roughly 3.8 hours. At cruising speed of 300 miles per hour, maximum range was approximately 1,140 miles. This was precisely enough to reach Berlin from English bases and return, but only barely, with no reserves for combat operations. Yet combat reports clearly indicated the American fighters had engaged in prolonged dogfights over Berlin, sometimes lasting 15 to 20 minutes, before disengaging and flying home. Combat power settings consumed fuel at rates exceeding 100 gallons per hour. Such expenditure should have left the aircraft unable to complete the return journey. The answer became apparent when technical staff examined the aircraft's wing structure more carefully. The P-51 featured standardized hardpoints under each wing, designed to accommodate external stores. These attachment points included fuel line connections, indicating they were specifically designed for external fuel tanks. The question wasn't whether the Americans were using drop tanks, but rather what capacity these tanks had, and how they were producing enough to maintain operational tempo. The search for American drop tanks from the March missions began immediately. Intelligence officers plotted likely jettison points based on engagement locations reported by Luftwaffe pilots. Drop tanks would typically be released when enemy fighters were encountered, as the external stores reduced maneuverability and speed. Search teams composed of Wehrmacht personnel and Hitler Youth volunteers spread across the countryside northeast of Berlin, looking for any debris from the air battles. Within 3 days, several objects were recovered from fields and forests in the region. Most were fragmentary, crushed on impact or damaged by the fall, but 2 examples arrived at Rechlin in relatively intact condition, having landed in soft soil or winter wheat that cushioned their impact. What German engineers discovered when they examined these recovered drop tanks would profoundly affect their understanding of American industrial capacity and the fundamental nature of the war they were fighting. The captured tanks were cylindrical, measuring approximately 108 inches in length, with a diameter of roughly 22 inches at the widest point. Capacity calculations indicated each tank held approximately 108 U.S. gallons. 2 such tanks would provide 216 additional gallons of fuel, extending the P-51's total fuel capacity to 485 gallons. With this fuel load, the Mustang could fly for approximately 6.7 hours at cruise power settings, yielding a range exceeding 2,000 miles. The fuel capacity mathematics now made sense. The P-51's Berlin mission profile was not only possible but left substantial margins for combat operations and emergencies. But what captured the immediate attention of German engineers was not the capacity of the tanks, but rather their construction. The drop tanks were not made of metal. Running a hand along the surface revealed a texture unlike aluminum or steel. The silver paint coating the exterior could not disguise the fundamental nature of the material beneath. When engineers carefully scraped away a small section of the paint near the tail cone, they found multiple layers of heavy paper, each layer perhaps 0.5 millimeter thick, compressed and laminated together with a resinous adhesive. The construction was sophisticated and purposeful. The nose cone and tail cone were formed from overlapping pieces of the paper material, pressed into shape, each piece visible as a slight ridge where it overlapped with adjacent pieces. The center section was seamless, wrapped around a cylindrical form in continuous layers. The fuel fittings were brass, precisely machined and properly sealed. The interior was coated with what appeared to be a cellulose-based lacquer designed to resist the corrosive effects of aviation gasoline. German materials specialists analyzed the tank's construction in detail. The paper was kraft paper, manufactured using a chemical pulping process that produced exceptionally strong cellulose fibers. The adhesive was phenolic resin, a thermosetting polymer that created bonds stronger than the paper itself when heat-cured. The lamination involved at least 12 separate layers of paper, each carefully oriented to provide strength in multiple directions. Anti-slosh baffles made of wood were installed inside to prevent fuel from surging during maneuvers. The entire construction process was clearly standardized and designed for mass production. The empty tank weighed approximately 80 pounds, compared to 65 to 75 pounds, for a comparable metal tank of smaller capacity. The paper construction wasn't significantly lighter than metal, but it offered other critical advantages that became immediately clear to the German technical staff examining it. The Americans were manufacturing fuel tanks from non-strategic materials. Paper and wood-based resins did not require aluminum, steel, or other metals that were increasingly scarce in wartime economies. The manufacturing process required no specialized metalwork equipment, no skilled metal workers, no welding or forming of sheet metal. These tanks could be produced in any paper mill or packaging factory with relatively simple modifications to existing equipment. The United States had hundreds of such facilities. If even a small percentage of American paper production had been converted to drop tank manufacturing, output could reach thousands of units per week. The tanks appeared to have no serial numbers, no manufacturer markings, nothing to indicate limited production runs or careful inventory control. They were commodity items, mass-produced and completely expendable. Intelligence officers began researching American paper industry capacity. The United States produced approximately 12 million tons of paper annually before the war, with production increasing during wartime mobilization. Converting even 1% of this capacity to drop tank production would yield over 100,000 tanks per month, far exceeding any plausible requirement for P-51 operations. Further analysis revealed additional details about the paper tank's design and operational use. The tanks were strictly single-use items. The phenolic adhesive, while creating strong bonds when cured, was slowly dissolved by prolonged contact with aviation gasoline. Intelligence reports and interrogations of captured American aircrew indicated that paper tanks had to be filled immediately before flight and could not be stored for more than a few hours without developing leaks. This wasn't a limitation that affected operational use. Fighters were fueled as part of pre-flight preparation. The tanks would be used for a few hours during the mission, then jettisoned. The single-use nature actually simplified logistics. There was no need to recover and reuse the tanks. No need for cleaning, inspection, or maintenance. They were expendable by design. The German evaluation also noted the color coding. Paper drop tanks were painted silver, while metal tanks used by American forces were painted gray. This color distinction allowed ground crews to quickly identify tank types during fueling operations. The silver finish on paper tanks also helped reflect solar heat, reducing fuel evaporation and vapor pressure issues at altitude. Every aspect of the design reflected systematic engineering optimization for mass production and field use. By late March 1944, German intelligence had traced the origin of the paper drop tanks to British development. The Air Ministry in London had commissioned development of impregnated paper fuel tanks in 1943 to conserve strategic metals, particularly aluminum. The Bowater-Scott Corporation, utilizing expertise in paper manufacturing, developed the production process. The tanks entered service with Royal Air Force fighter squadrons in late 1943. American forces quickly adopted the design, with multiple manufacturers in both Britain and the United States producing tanks for use by U.S. Army Air Force's fighter groups. The innovation had been driven by British resource scarcity, but was being exploited on a massive scale by American industrial capacity. The broader implications extended far beyond fuel tanks. German technical staff began a systematic review of captured American equipment, looking for other examples of industrial innovation and mass production techniques. The results painted a consistent and deeply troubling picture. American equipment was not always technologically superior to German equivalents in terms of individual component performance. German optics were often better. German small arms were often more sophisticated in design. German armor metallurgy was, in some respects, more advanced. But American equipment was consistently better manufactured, more standardized, more reliable, and available in vastly greater quantities. The American approach prioritized producibility over perfection. Components were designed from the outset for mass production by semi-skilled workers using standardized tooling. Parts were interchangeable between units without hand-fitting. Assembly line methods reduced production time and increased output. The contrast with German production methods was stark. German weapons and equipment were often technical masterpieces, hand-fitted by skilled craftsmen. A German tank or aircraft engine represented the peak of precision engineering, but building such equipment required skilled labor, specialized tools, and significant time per unit. Production rates were constrained by the availability of master craftsmen and precision manufacturing equipment. The Germans built superior individual items. The Americans built adequate items in overwhelming quantities. In industrial warfare, quantity was proving decisive. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Analysis of P-51 Mustang production illustrated this principle with brutal clarity. North American Aviation had designed the original Mustang prototype in response to a British requirement in 1940. The prototype was completed just 117 days after the contract was signed, one of the fastest design-to-prototype cycles in aviation history. The first flight occurred on October 26, 1940. By 1944, North American was producing P-51 variants at 2 facilities. The Inglewood plant in California averaged approximately 364 Mustangs per month during peak production periods. The Dallas plant contributed additional production. Combined output across both facilities reached an average of approximately 574 P-51s per month during 1944, with production accelerating throughout the year. Each P-51 required approximately 15,000 individual parts manufactured by hundreds of subcontractors across the United States. The Packard-built Merlin engines were produced in Detroit at rates exceeding 300 units per month. Final assembly of a P-51D required approximately 22,000 man-hours of labor, but the production line system meant that completed aircraft rolled out of the factory at intervals of just a few hours. At peak efficiency, a new Mustang was completed approximately every 2 hours. The scale and efficiency of this production system exceeded anything Germany had achieved. Messerschmitt and Focke-Wulf combined produced approximately 600 fighters per month in early 1944. Despite operating under emergency priority programs and utilizing forced labor, German aircraft production could not match American output. The resource implications were equally sobering. American aluminum production in 1944 reached approximately 1.25 million tons, equivalent to £2.5 billion annually. This represented a massive increase from pre-war production of approximately 164,000 tons in 1939. Germany's aluminum production, by contrast, peaked at approximately 250,000 tons per year and was declining due to bombing of production facilities and loss of bauxite sources. The Americans had approximately 10 times Germany's aluminum production capacity. The decision to manufacture drop tanks from paper rather than aluminum was not driven by metal scarcity. The United States had sufficient aluminum to produce every drop tank in metal if desired. Paper was chosen because it was cheaper, required less critical manufacturing equipment, freed aluminum for other uses, and could be produced more quickly with less skilled labor. This was optimization, not desperation. The psychological impact of these revelations spread through the Luftwaffe technical and operational communities. The paper drop tank became a symbol of American industrial capability and the fundamental disparity in resources between the combatants. Captured examples were displayed at technical briefings for Luftwaffe personnel. Pilots transitioning to fighter units were shown the tanks and asked to calculate the implications for combat tactics. The message was clear and unavoidable. American fighters could now escort bombers anywhere in Germany. The previous defensive strategy of waiting for Allied fighters to reach their fuel limits and turn back was obsolete. Luftwaffe fighters would have to engage the escorts to reach the bombers, and those engagements would cost aircraft and pilots at rates Germany could not sustain. Galland provided operational assessments in conferences with senior Luftwaffe leadership throughout the spring of 1944. The P-51 was superior to German fighters above 20,000 feet, he emphasized repeatedly. It was faster than the Bf-109 at altitude and more maneuverable than the FW-190. With the extended range provided by drop tanks, it could escort bombers throughout their mission profile. German fighters could no longer attack bomber formations unopposed after Allied escorts turned back. Every intercept now required fighting through the fighter screen first. Loss rates were climbing steadily and unsustainably. In January 1944, the Luftwaffe lost approximately 90-day fighters, while claiming approximately 150 Allied aircraft destroyed. By February, German losses had increased to approximately 160 aircraft, against approximately 230 Allied losses. The trend was clear. Even if German pilots' victory claims were accurate, which post-war analysis would show they often weren't, the Americans and British could replace losses faster than Germany could inflict them. The summer of 1944 brought the full catastrophic impact of American escort fighter capability. The 8th Air Force conducted deep penetration raids almost daily when weather permitted. Mustangs provided continuous escort from England to targets across Germany and back. Luftwaffe fighter losses mounted at rates that could not be sustained. In June 1944, approximately 350-day fighters were lost defending the Reich. In July, Losses exceeded 350 single-engine fighters in the West alone, representing a monthly attrition rate of over 31%. August saw similar devastation with a 36% attrition rate. At these loss rates, experienced pilots were being killed faster than they could be replaced. The replacement pilots arriving from training schools had perhaps 150 hours of flight time, compared to 300 hours or more for American pilots. Many German replacement pilots had as little as 30 hours in type before being assigned to operational squadrons. The experience gap, combined with numerical inferiority and the constant presence of P-51 escorts, made daylight operations over Germany increasingly deadly for Luftwaffe fighter forces. Galland submitted repeated assessments to Hitler and senior Wehrmacht leadership throughout this period. His September 1944 report stated the situation bluntly. The Luftwaffe could not win the air war. Germany lacked the resources, the fuel, the aircraft, and the trained pilots necessary to contest Allied air superiority. The Americans could replace losses faster than Germany could inflict them. Their industrial capacity was beyond Germany's ability to counter through combat operations. The only viable strategy was to husband remaining resources for defense of critical targets and hope for political settlement before complete collapse. The paper drop tanks continued to fall across Germany throughout late 1944 and into 1945. German civilians learned to recognize the distinctive cylindrical shapes lying in fields and forests. Initial reports sometimes described them as unexploded bombs, causing local panic until military authorities identified them as harmless fuel tanks. Instructions were distributed through civil defense organizations, explaining that the silver cylinders falling from Allied aircraft were empty fuel tanks, not weapons. The psychological impact was noted in civilian morale reports. The sight of enemy aircraft overhead in such numbers that their contrails crisscrossed the sky, casually discarding expendable fuel tanks, reinforced the message that the Allies had resources to waste, while Germany scraped for every litre of fuel and every kilogram of aluminum. Technical intelligence continued analyzing captured American equipment throughout 1944, but the focus shifted from understanding capabilities to simply documenting the scale of industrial disparity. Could Germany manufacture similar paper drop tanks? The technical answer was yes. The German chemical industry could produce suitable resins. German paper mills could manufacture kraft paper. The manufacturing process was not particularly sophisticated, but the practical answer was no. Germany's chemical industry was already operating at maximum capacity, producing synthetic rubber, explosives, and other critical materials. Resin production for non-essential items could not be prioritized. The paper industry was fully committed to military requirements for maps, documents, and packaging. Most critically, there was no operational requirement for extended-range drop tanks. By late 1944, fuel shortages were grounding large portions of the Luftwaffe. Pilot training was reduced to minimal levels. Operational sorties were limited by fuel availability rather than aircraft availability. Building drop tanks to extend range was meaningless when there was barely enough fuel for local defensive operations. The irony was stark and bitter to German planners. The Americans had solved the fighter range problem with paper fuel tanks at exactly the time when German fighters were grounded by fuel shortages. Different problems, different industrial bases, different outcomes. The Americans had more of everything: more aircraft, more fuel, more pilots, more aluminum, more industrial capacity, and sufficient excess capacity to optimize solutions like paper drop tanks. Germany was fighting a war of scarcity against an enemy for whom scarcity was not a constraint. By January 1945, the war's outcome was beyond doubt. Soviet forces were approaching the Oder River, less than 50 miles from Berlin. Western Allied forces had recovered from the Ardennes offensive and were pushing toward the Rhine. The Luftwaffe could mount only sporadic resistance, limited by fuel availability and catastrophic pilot losses. The systematic study of American equipment continued at Rechlin, but it had become an academic exercise. The findings were documented for the historical record, but they could no longer influence the war's outcome. The final comprehensive analysis of the P-51 and its drop tanks was prepared in late January 1945. The report documented every technical aspect of the Mustang's range capability, the drop tank construction methods and materials, production estimates, and operational implications. The conclusion was unambiguous. The P-51 Mustang, equipped with expendable paper drop tanks manufactured from non-strategic materials, had rendered the German heartland indefensible against American daylight bombing. Germany lacked the industrial capacity to match American fighter production, the fuel to sustain combat operations at the required scale, and the trained pilots to replace losses at current attrition rates. The report was filed in Reich Air Ministry archives in late January 1945. Whether senior leadership read it is unknown. By then, technical reports analyzing American capabilities were simply confirming what battlefield reality had already demonstrated. The Luftwaffe, which had dominated European skies in 1940, was reduced to occasional desperate sorties by early 1945, hoarding precious fuel for missions that could not change the strategic situation. American fighters roamed freely over Germany, attacking targets of opportunity, escorting bombers, establishing complete air supremacy. The psychological warfare aspect of the paper drop tanks extended beyond their functional purpose. Each tank falling from American aircraft carried an implicit message that German civilians and military personnel alike could read clearly. The Allies possessed such overwhelming resources that they could manufacture fuel tanks from paper, use them once, and discard them. No need to recover them, repair them, or reuse them. They were industrial artifacts that spoke to abundance rather than scarcity, optimization rather than desperation. Captured Luftwaffe documents reveal that morale officers tracked civilian reactions to the continuous stream of Allied aircraft overhead. Reports from cities across Germany noted the demoralizing effect of seeing hundreds of American fighters escorting bomber formations, the contrails marking the sky like a grid pattern, the occasional silver cylinder tumbling from altitude to land in a field or forest. German propaganda attempted to frame these discarded tanks as evidence of Allied wastefulness, but the message received by most Germans was simpler and more troubling. The enemy had so much of everything that they could afford to throw away what Germany struggled to produce. The June 1944 exhibition at Rechlin had displayed captured Allied aircraft to Luftwaffe personnel, including multiple examples of the P-51 Mustang alongside B-17 and B-24 bombers, P-38 Lightnings, Lancaster bombers, Mosquito fighter bombers, Typhoon fighter bombers, and various Spitfire variants. Thousands of Luftwaffe pilots and ground personnel toured the exhibition, examining enemy equipment firsthand. The paper drop tanks were displayed prominently with technical diagrams explaining their construction and range implications. The exhibition served as both an educational tool and sobering reality check. German personnel could see the quality of Allied equipment, the standardization of components, the evidence of massive production capacity. The overwhelming scale of Allied industrial mobilization was made tangible through the physical examples of equipment they faced in combat daily. For many who attended, this was the moment when theoretical understanding of industrial disparity became visceral knowledge. They were not fighting an enemy that was barely surviving. They were fighting an enemy that was thriving, innovating, and overwhelming them through sheer productive capacity. Kampfgeschwader 200, the Luftwaffe unit responsible for special operations, including flying captured Allied aircraft, operated several P-51's throughout 1944. These aircraft were used for evaluation flights, allowing Luftwaffe test pilots to experience firsthand the performance characteristics that made the Mustang such an effective fighter. The reports from KG 200 pilots consistently noted the P-51's excellent visibility from the cockpit, particularly in the later P-51D model with its bubble canopy. The aircraft was stable in flight, responsive to controls, and possessed excellent high-altitude performance. The Merlin engine provided smooth, reliable power throughout the operating envelope. Most significantly, the range and endurance were extraordinary for a single-engine fighter. With full internal fuel and drop tanks, the P-51 could remain airborne for over 6 hours, flying missions that would have been impossible for German single-engine fighters, even with external tanks. One test pilot's report, preserved in archives, noted with professional detachment that the Mustang's combat radius exceeded the distance from any German airfield to any target in Allied-controlled territory. The strategic implication was clear. German fighters had to defend everywhere simultaneously. American fighters could concentrate their forces anywhere they chose. The technical understanding gained at Rechlin contributed to German defensive tactics in the final year of the war. Recognizing that American fighters could escort bombers throughout their missions, Luftwaffe fighter controllers attempted to concentrate forces at specific points to achieve local numerical superiority. This required careful coordination and timing, as dispersed German units had to assemble at designated locations to create formations large enough to have a chance against the heavily escorted bomber streams. Fuel constraints and communication difficulties often prevented successful concentration. Even when German fighters achieved favorable positions, the presence of P-51 escorts made attacks on the bomber formations extremely costly. The tactical situation had fundamentally shifted. In 1943, unescorted or poorly escorted bomber formations had suffered catastrophic losses. By mid-1944, German fighters attempting to reach the bombers suffered catastrophic losses. The defensive advantage had transferred completely to the side, with greater range, greater numbers, and greater industrial capacity to replace losses. The story preserved in technical reports and post-war interviews reveals the psychological impact on German technical personnel. They were not analyzing a superior weapon in the traditional sense. The paper drop tank was not an advanced technology. It was, in fact, a deliberately simplified design using non-critical materials. But that very simplicity carried a message more devastating than any technical sophistication could have conveyed. The Allies had such overwhelming industrial capacity that they could afford to optimize designs for mass production rather than performance. They could manufacture fuel tanks from paper because they had unlimited paper, unlimited resin, unlimited manufacturing capacity, and unlimited fuel to put in the tanks. The optimization was not driven by scarcity but by efficiency. Germany's experienced engineers understood immediately what this meant. They were not fighting an enemy that was desperately improvising with substitute materials. They were fighting an enemy so wealthy in resources that substitution was a choice made for efficiency, not a necessity imposed by shortage. This realization, coming in early 1944 when significant fighting still lay ahead, shaped the assessments and recommendations of German technical staff throughout the remainder of the war. Post-war interrogations of Luftwaffe personnel consistently returned to this theme. When asked when they first understood that Germany would lose the war, many technical staff and senior officers cited the early spring of 1944 as the turning point. The arrival of long-range fighter escorts over Berlin marked a decisive shift in the strategic balance that no amount of tactical skill or operational innovation could overcome. Hermann Göring, interrogated after the war, acknowledged that long-range fighters had delivered a major strategic blow to German defensive planning and were among the most decisive factors in the ultimate outcome of the air war. While specific quotes attributed to Göring about Mustangs over Berlin remain difficult to verify in primary sources, his post-war statements consistently acknowledged that Allied air superiority, made possible by long-range escort fighters, had been decisive in Germany's defeat. The technical lessons learned by German engineers who examined captured P-51's and their drop tanks contributed to post-war aviation development. Many of these engineers immigrated to the United States or worked with Allied technical intelligence services after the war. Their detailed understanding of American production methods and design philosophy influenced their later work. The emphasis on standardization, interchangeability of parts, and design for manufacturability became standard practice in post-war aircraft development. The paper, drop tank itself, became a case study in wartime industrial innovation, taught in engineering schools and military staff colleges as an example of how resource optimization and mass production could provide strategic advantage. The lesson was clear. The best solution is not always the most sophisticated. The best solution is the one that meets requirements while being manufacturable in the quantities needed, within the time available, using accessible resources. The P-51 Mustang continued in service with various air forces for decades after World War II. The aircraft saw extensive combat in the Korean War, serving primarily in ground attack and close air support roles. The excellent range and endurance that had made it an outstanding escort fighter in Europe proved equally valuable in the very different operating environment of Korea. P-51s remained in frontline service with some air forces into the early 1980s, testament to the soundness of the basic design. More than 15,000 Mustangs were produced during and immediately after the war, making it one of the most numerous American fighters of the era. Today, over 100 P-51s remain airworthy, maintained by collectors and museums worldwide. The sight of a Mustang in flight, often still wearing the distinctive markings of wartime units, serves as a reminder of the aircraft's role in establishing Allied air supremacy over Europe. But the deeper significance lies not in the aircraft itself, but in what its operational capability represented. The broader historical significance of the P-51 and its paper drop tanks extends beyond their tactical and operational impact. They represent a case study in industrial warfare and the importance of production capacity in modern conflict. World War II was decided not primarily on the battlefield, but in factories. The side that could produce more weapons, more ammunition, more aircraft, more vehicles, and more supplies faster, than they were consumed in combat, held a decisive advantage that tactical excellence could not overcome. The United States achieved industrial mobilization on a scale unprecedented in history. Peak wartime production in 1943 to 1944 saw American factories producing aircraft at rates exceeding 50,000 per year, ships at rates of multiple vessels per day, and ammunition in quantities measured in billions of rounds. This industrial output supported not only American forces but also supplied substantial quantities of equipment to Britain, the Soviet Union, and other Allied nations through Lend-Lease. Germany, despite possessing significant industrial capacity and technical expertise, could not match Allied production. The reasons were multiple. A smaller industrial base to begin with, strategic bombing of production facilities, loss of access to raw materials as territory was lost, diversion of resources to competing priorities, inefficiencies in organization and planning. But perhaps most fundamentally, Germany was fighting a coalition whose combined industrial capacity was several times larger than its own. The addition of American industrial might to the Allied cause in 1942 to 1943 made Axis defeat inevitable once that industrial capacity reached full mobilization. The paper drop tanks falling across Germany in 1944 to 1945 symbolized this industrial reality in a form so simple and so stark that its message could not be misunderstood. The examination of captured American equipment by German technical intelligence services had been systematic and professional throughout the war. Facilities like Rechlin maintained detailed records of performance testing, material analysis, and technical assessments. These documents, many of which survived the war in various archives, provide valuable historical insight into how each side viewed the other's capabilities. German assessments of American equipment were generally accurate in technical terms. They correctly identified strengths and weaknesses of American aircraft, vehicles, and weapons. Where German analysis failed was not in understanding individual items, but in comprehending the scale of American production and the implications of that scale for the war's outcome. A single P-51 Mustang was a very good fighter aircraft. 10,000 P-51 Mustangs represented air superiority that no tactical skill or technical innovation could overcome. The story of German engineers examining paper drop tanks at Rechlin in March 1944 is ultimately a story about the nature of industrial warfare. It demonstrates that in conflicts between industrialized nations, production capacity becomes as important as battlefield prowess. The side that can build more, faster, and more efficiently holds advantages that tactical and operational excellence cannot fully compensate for. This lesson, learned at great cost by Germany and Japan in World War II, influenced military planning throughout the Cold War and continues to inform strategic thinking today. The ability to sustain production of advanced weapons systems, to maintain supply chains under stress, to train personnel faster than they are lost in combat, and to outproduce an opponent over extended periods remains as critical now as it was in 1944. The March 1944 missions to Berlin, the first to be escorted all the way by single-engine fighters, marked a decisive turning point in the air war over Europe. From that point forward, no target in Germany was beyond the reach of American bombers with fighter escort. The systematic bombing campaign could proceed with losses that, while still significant, were sustainable. German war production came under increasing pressure. Synthetic fuel plants, ball-bearing factories, aircraft production facilities, and transportation networks all became targets that could be attacked repeatedly with fighter escort throughout the mission. The cumulative effect of this campaign, combined with Soviet advances from the east and Allied advances from the west and south, brought about Germany's defeat 14 months after the first P-51's reached Berlin. The paper drop tanks served throughout this final period of the war. Production continued through 1945, with thousands manufactured each month. The tanks were used not only by P-51 Mustangs but also by P-47 Thunderbolts and P-38 Lightnings, extending the range of all American fighter types. British fighters also used paper tanks extensively. The Royal Air Force's Mustang squadrons employed them for long-range missions over occupied Europe and Germany. The efficiency of paper tank production freed aluminum and steel for other uses, while providing the range extension necessary for strategic operations. This optimization of resources, matching production methods to requirements, and prioritizing efficiency over tradition, exemplified the industrial approach that characterized Allied operations throughout the war. Today, historians studying the air war over Europe recognize multiple factors that contributed to Allied victory. Numerical superiority in aircraft and pilots, technological advantages in areas like radar and communications, strategic bombing of German industry and infrastructure, and the cumulative effect of sustained combat operations that depleted German resources faster than they could be replaced. The P-51 Mustang and its paper drop tanks were important elements in this multifaceted campaign, but not the sole decisive factor. The air war was won through the combined efforts of multiple fighter types, bomber forces, industrial production, pilot training, intelligence gathering, tactical innovation, and sustained commitment of resources. The paper drop tank represents one component of this larger effort, notable because it so clearly symbolizes the industrial advantages that underlay Allied success. The technical files maintained at Rechlin documented American capabilities with professional precision. German engineers recorded specifications, performance data, construction methods, and production estimates with the thoroughness characteristic of German technical work. These records, preserved in various archives including the Bundesarchiv, provide historians with detailed contemporary assessments of Allied equipment as seen through German eyes. Reading these documents today, with the benefit of historical hindsight and access to American records, reveals that German technical analysis was largely accurate. They correctly understood American capabilities. What they could not change was the strategic reality those capabilities represented. Understanding that an enemy possesses overwhelming advantages does not provide the means to counter those advantages when they are rooted in fundamental disparities of industrial capacity and resource availability. The legacy of the paper drop tank extends beyond its wartime use. It serves as a reminder that effective solutions need not be sophisticated or technically impressive. A tank made from glued paper, designed for single use, manufactured from non-critical materials, represented an appropriate solution to the specific problem of extending fighter range. It was good enough for the mission. This principle, designing solutions that are adequate for purpose rather than pursuing technical perfection, became a fundamental concept in modern systems engineering. The best solution is not always the most sophisticated. The best solution is the one that meets requirements while being manufacturable in the quantities needed within the time available, using accessible resources. This lesson, taught by paper drop tanks falling across Germany, remains relevant in military and civilian applications today. The aircraft that carried those drop tanks, the P-51 Mustang, stands as one of the most successful fighter designs in aviation history. Its combination of range, performance, reliability, and producibility made it an ideal escort fighter for the strategic bombing campaign. The Mustang's success resulted from multiple factors: the aerodynamically efficient airframe designed by North American Aviation's engineering team led by Edgar Schmude, the powerful and reliable Merlin engine, the addition of the fuselage fuel tank extended range, and the availability of drop tanks that pushed operational radius beyond 800 miles. No single element created the Mustang's effectiveness. It was the successful integration of all these components, supported by industrial capacity to produce them in quantity, that made the P-51 the decisive escort fighter of the European Air War. 80 years after the events of March 1944, the lessons remain instructive. The examination of captured equipment by German engineers at Rechlin revealed not just technical details, but strategic realities. The paper drop tanks demonstrated that the United States possessed industrial capacity beyond Germany's ability to match, that American engineering emphasized practical solutions over technical perfectionism, and that the Allies had sufficient resources to optimize for efficiency rather than make desperate substitutions. These revelations, coming in March 1944, when the war's outcome was not yet certain but the trajectory was increasingly clear, provided German technical staff with understanding of the challenges they faced. That understanding could not change the outcome. Germany's defeat was determined by factors beyond the control of engineers at testing facilities, but the story of those engineers examining paper cylinders of glued kraft paper, calculating fuel capacities, and recognizing the implications for the air war provides insight into how industrial capacity determines the outcome of modern conflicts. The war ended in May 1945. The systematic bombing campaign, enabled by long-range fighter escorts, including the P-51 Mustang, had contributed significantly to Germany's defeat. Industrial production had been disrupted, transportation networks were devastated, fuel supplies were exhausted, the Luftwaffe was reduced to a token force. These outcomes resulted from many factors operating over several years, but the ability to escort bombers throughout their missions over Germany, made possible by fighters like the P-51 carrying drop tanks, including those made from paper, was among the decisive elements. The paper drop tanks themselves, those that survived, became historical artifacts. A few found their way to museums. Most were destroyed or discarded as the debris of war. Their significance lies not in the objects themselves, but in what they represent. Industrial capacity applied with strategic purpose, appropriate technology solving specific problems, and the decisive advantage of overwhelming production capability in modern warfare. For the Luftwaffe aces who had built their defensive strategy on the assumption that American fighters could not reach Berlin with combat reserves, the appearance of Mustangs over the Reich capital in March 1944 represented a moment of profound strategic clarity. The mathematics they had relied upon were correct for the aircraft they knew, but those calculations had not accounted for American industrial innovation applied at massive scale. Paper tanks holding 108 gallons each, 2 per aircraft, range extended from barely sufficient to operationally dominant. The transformation happened with shocking speed. February 1944, the last month when German fighters could still wait for Allied escorts to reach fuel limits. March 1944, the first missions to Berlin with continuous fighter escort. By summer 1944, American fighters ranged over all of Germany, attacking at will. The defensive strategy built on Allied range limitations became obsolete in weeks. The tactical adjustments required to counter this new reality exceeded Germany's capacity to implement them. Not because German pilots lacked skill or courage, not because German aircraft were technically inferior in all respects, but because the industrial disparity was too great to overcome through operational excellence. The Luftwaffe's experienced aces understood this with painful clarity. Men like Galland, with over 100 victories, possessing tactical expertise gained through years of combat, found themselves advocating for strategic withdrawal and resource conservation because there was no tactical solution to strategic industrial inferiority. Their reports to senior leadership throughout 1944 documented not just battlefield losses, but the systematic erosion of Germany's ability to contest Allied air superiority. Each report acknowledged that while individual German pilots might achieve favorable exchange ratios in specific engagements, the overall trend was unsustainable. The Americans replaced losses faster than Germany could inflict them. Every month, the disparity widened. By late 1944, the question was not whether Germany would lose air superiority, but how long they could delay the inevitable while hoping for political settlement or some technological breakthrough that might alter the strategic balance. The technological breakthrough they hoped for, the Me-262 jet fighter, did arrive in operational quantities by early 1945. Fast enough to outrun any Allied fighter, armed with cannons and rockets capable of destroying heavy bombers with single hits. But even this remarkable aircraft could not change the outcome. Fuel shortages limited operations. The few available jets were overwhelmed by sheer numbers of Allied fighters, and critically, the jets had to fix T-band eventually, making them vulnerable to the hundreds of American fighters patrolling over German airfields. Technology alone, even revolutionary technology, could not compensate for industrial disparity. The final missions over Berlin in March and April 1945 saw American bombers escorted by overwhelming fighter formations. German opposition was sporadic and ineffective. The Luftwaffe that had terrified Europe in 1940 was reduced to isolated, desperate attempts to interfere with Allied operations. The transformation from dominance to defeat had taken less than 5 years, but the decisive turning point, the moment when outcome became inevitable rather than merely probable, was that spring day in March 1944 when P-51 Mustangs appeared over Berlin. The paper-drop tanks that made this possible were never celebrated as war-winning weapons. They received no propaganda attention, no dramatic newsreel coverage, and no place in the popular memory of the war. They were logistical enablers, unsexy but essential. The ground crews who mounted them on aircraft pylons at 3 a.m. performed their work without recognition. The factory workers who manufactured them from compressed paper and resin never saw their products in use. The engineers who designed them optimized for production efficiency rather than technical elegance. Yet their contribution to Allied victory was profound and measurable. Without extended-range drop tanks, P-51s could not escort bombers deep into Germany. Without that escort, bomber losses would have remained at unsustainable levels. Without sustainable bomber operations, the systematic destruction of German war production would have been impossible. The strategic bombing campaign, for all its controversial aspects and debated effectiveness, depended absolutely on fighter escorts that could match bomber range. The paper-drop tank solved that problem with elegant simplicity. Watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.